Hello everyone. In this video, we're going to be taking a look at part 2 of the Fundamental Theorem of Calculus. Part 1 of the theorem gave us a relationship between the integral of a function and its antiderivative. Part 2 of the theorem is going to give us a way that we can evaluate a definite integral without having to use Riemann sums. So what part 2 of the Fundamental Theorem of Calculus says: if we have a definite integral, so let's do an integral from a to b, so our closed interval here, of a function lowercase f of x times dx, we're going to be using the antiderivative. So this integral is going to be equal to capital F of b minus capital F of a. And written like this, capital F is going to be any antiderivative of the function lowercase f of x. So we have the antiderivative evaluated at the upper bound of our integral minus the antiderivative evaluated at the lower bound of our integral. So that's what part 2 says. And now let's use this in just a couple quick examples. So the first example, I have the integral from -2 to 1 of x squared times dx. So the first thing we need to do is we need to find the antiderivative of x squared. So this is where the part 1 of the Fundamental Theorem of Calculus comes in. So the antiderivative of x squared, so we're going backwards, so I need to increase the exponent by 1, so that gives me x cubed. And then to make sure that our coefficient simplifies properly, I'm going to divide by 3. So if I were to take the derivative of this, the 3 would come down out front. I would subtract 1 from that exponent, give me the x squared that I'm looking for, and then 3 over 3 would simplify. And now the notation that we're going to use here, this is our antiderivative, and I want to evaluate this on a certain interval. So I'm going to put it in brackets, and then I'm going to note from -2 to +1. So now I'm going to take both of these values, I'm going to plug it into what we found, and that's going to evaluate this integral. So we start with the upper bound, so we have 1 cubed over 3, and then we're going to subtract this evaluated at the lower bound. So -2 cubed over 3. So 1 cubed, we get 1/3, and then I'm going to subtract. -2 cubed is -8, so -8 over 3. So the negatives will cancel out, so we're going to end up with 1/3 plus 8/3, which is 9 over 3, which all simplifies to +3. So this integral from -2 to 1 of x squared times dx, we end up with an answer of 3. So let's go through that process one more time. So the integral from 0 to pi over 6 of cosine of x times dx. So again, just to begin with, we need to find the antiderivative of the cosine of x. The antiderivative of cosine is sine because the derivative of sine is cosine. And then we're going to evaluate this from 0 to pi over 6. So what we want is we want the sine evaluated at our upper bound, and then we're going to subtract the sine evaluated at the lower bound. And now to finish this up, the sine of pi over 6, that is equal to 1/2. The sine of 0 is 0. So our definite integral from 0 to pi over 6 of the cosine of x times dx, this is all equal to 1/2. So that's how we use part 2 of the Fundamental Theorem of Calculus. We find the antiderivative of the function, and then we do the antiderivative evaluated at the upper bound, and we subtract the antiderivative evaluated at the lower bound.